Last part of this chapter is about the calculations on acidic and basic properties and questions. Let's start with self-ionization concept of water. Let's write this equation for two water molecules because it's about just water molecules. When we say self-ionization of water, means one of the water molecules acts as acid and another one acts as base because we don't have anything else, right? So if this is acid, it will lose one hydrogen ion, it will change to OH, and the other one will accept the hydrogen, so it will change to H3O. Correct? So we have a conjugate acid-base pair. This is the conjugate base, and this is the conjugate acid, right? We have an acid and a base on each side. For such a reaction, you can write K equilibrium, right? K equilibrium. Because it's about water, let's name it KW, W for water. So you remember that we need to put the molar concentrations of products times to the power of their coefficients divided by molar concentration of the reactants. And we said we do not write the concentration of the reactants and products if they are in the liquid or solid form. So because these are in the liquid form, we won't write it. So Kw is molar concentration of H times OH. This amount at 25 degrees Celsius, which is considered the room temperature, has been measured, which is 1 times 10 to 14. To negative 14, I'm sorry. 10 to negative 14. So this is the first formula. This will be given in the test, but you are supposed to know how to work with them. And I'm going to work only on solutions of strong acids and bases with you at the end of this chapter. Solutions of strong acids or strong bases, and I tell you why. So why do we say, and what do we say if you forgot what is a strong acid or a strong base? Let's say like HCl. A strong acid, you will see this arrow for it. It's called irreversible reaction. So for a strong acid, you have an irreversible reaction, means 100% ionization. 100% ionization. You don't see an equilibrium sign, right? It's just a one-way arrow. So because we need this to work on the stoichiometry of these calculations, we work on a strong acid or base, or the same thing for a strong base, Na and OH. Again, you see an irreversible sign. We're not working with the solutions which are in equilibrium. All right, so we are going to work on question on slide number 38. It's asking to calculate the hydronium and hydroxide ion concentrations of first 0.1 molar HCl. So when you have HCl, you just remember I told you it dissociates completely to hydrogen and chloride. So 0.1 molar is going to form 0.1 molar and 0.1 molar of hydrogen and Cl. So the concentration of hydrogen and Cl, and the coefficients are 1 also, is both 0.1 molar. That's for when you are dealing with a strong acid. A strong base, MgOH2, Mg, positive 2, plus how many hydroxide ions to balance it out? 2. So when you have, it's giving you 1.4 times 10 to negative 4 molar. When you have that, so then you have the same amount for Mg because the equations are the same, but you have twice as that, so you have 2 times 1.4 times 10 to negative 4 molar, which is 2.8 times 10 to negative 4 molar. So pay attention to the coefficients. After knowing how to deal with these strong acids and bases and how to determine their concentration of their hydrogen and hydroxide ions, let's work on the scale, acidic scale. When we have an acidic solution, means the concentration of hydronium ion is high, is higher than 1 times 10 to negative 7 molar. Neutral means that concentration of hydronium ion is about 1 times 10 to negative 7 molar. And when you have a basic solution, concentration of hydronium ion is less than 1 times 10 to negative 7 molar. This is what you need to memorize. And this comes from that KW, and you can easily find it from there, but you can also memorize them. So the next formula that you're going to work on is the pH. First of all, let's see what is pH. What does it stand for? pH is potential of hydrogen. Potential of hydrogen, pH. P of everything in math is minus log of that, right? So P of hydrogen ion is the minus log of that hydrogen ion. You remember that at the beginning of this chapter I told you hydrogen ion and hydronium ion are the same. So this is another formula that you need to work on. Again, it will be given in the exam, but you are supposed to know how to work with it. The same thing can be said for a basic solution, minus log of OH. Okay? Let's work on an example. Calculate the pH of typical adult blood, which has a hydronium ion concentration of 4 times 10 to negative 8 molar. So what was pH? Is minus log of H3O. You plug it into the formula and do the calculations on your calculators. So what did you get from your calculator? pH was 7.40. So if you are a healthy person, the pH of your blood must be around 7.40. So far we said pH is minus log of H. pOH is minus log of, or instead of H, just H, let's work with the hydronium ion. Minus log of OH. And then now you can say pH plus POH is going to be 14 at 25 degrees Celsius. Okay? So this is another, if for example pH is given, you're looking for POH, you just subtract it from 14. And then the opposite of these, if you are given the pH and POH and you're looking for finding the concentrations of H3O and OH, then the opposite of log is 10 to negative pH. Again, those are the formulas that will be given in the exam. No need to be worried about it. And it's going to be 10 to negative POH. Working on more questions. Slide number 45. The pH of natural rain. The pH of natural rain is 5.60. What is the hydronium ion concentration? What is the formula between pH and H3O when we need the H3O? It's 10 to negative pH. So it's 10 to negative 5.60. And put it in your calculators. What would be the concentration of H3O? Tell me. It would be 2.5 times 10 to negative 6 molar. If you needed to find the concentration of OH also, what would you say? Huh? You would say concentration of H, remember, H3O times OH. You can go to the very last slide of this chapter. Concentration of H times OH is 10 to negative 14. So concentration of OH is 1 times 10 to negative 14 divided by concentration of H3O. So it would be 1 times 10 to negative 14 divided by, you have the 2.5 times 10 to negative 6, and I don't have a calculator with me. You will just plug it in and find it. And if you need to find the POH, then from the OH, you will put the minus log of OH. Like here, I forgot to put a negative. So that's all about this chapter. Please make sure you work on all types of these problems. You have plenty, you can play with each of these, but you just have limited number of formulas to work on.